Hey folks, I'm going to be talking about metrics-driven data architectures. Now this is a topic that's had a lot of buzz recently, but it's also not a new topic, because what we're talking about is how organizations measure and track things they value, which is ultimately a core driver for why we have data teams and data infrastructures in the first place. So in this talk, I'm going to take us on a bit of a whirlwind tour of how different data architectures enable the gathering of organizational metrics. We'll look at past, present, and emerging trends, where we'll see that increasingly, metrics are becoming a first-class concern in data architecture design. I'm Ned Letcher, a data science engineer at ThoughtWorks. I'm a part of the Australian Data and AI practice, where we help organizations design and build data products, and also help them with their data strategy. Recently, I've been fixated on the question, how can we best enable data consumers within organizations? One of the conclusions I've come to is that I think we need to work on improving access to standardized and trusted metrics across the organization. To get started, let's first discuss metrics. I think it's helpful to unpack the two related concepts of metrics and measurement. A metric is an agreed standard for measuring something within a given context, whereas a measurement is a quantitative observation of a phenomenon. So thinking about a hypothetical product company, we could look at the metric of monthly recurring revenue as having an example measurement of $500,000 revenue generated from sales in July. The metric of monthly churn rate could have an example of 150 customers who cancelled their subscription in July. And then the metric of click-through rate could have an example measurement of the 1.5 million ad impressions in July, 30,000 people clicked through. But what makes a good metric? I would argue that a good metric is aligned to your desired outcomes, is reliably measurable, and there's consensus over its definition. Also, that definition needs to be stable over time. Just unpacking that last point, looking at this data of pedestrian traffic from people travelling through Melbourne's central business district, it shows us the metric of hourly counts across sensors placed throughout the CBD. Now, we might look at this and be tempted to conclude that the amount of traffic increased greatly from 2013 to 2019. This would actually be misleading because I know that the number of sensors has actually increased substantially over time, meaning that we'll have duplicate counts for the same people traveling. So this means the metric values are actually not comparable over this time. So metrics do require some careful thought around their design. But why do we need metrics? Well, when used well, we can use metrics to support a number of important functions. The first of these is strategic decision-making, where they can help us answer questions of the form, are we going in the right direction? Such as, when is a good time to launch our new product? Should we be hiring more staff? We can also use them for goal setting, where they can help us build out OKR-style templates, like, we will know we have achieved our goal when we see metric A having value Y. It's important to note here that metrics are the indicators of success. They're the key results, not the objective. Because we need to be wary of falling into the trap of Goodhart's law, which says that when a measure becomes a target, it ceases to be a good target. Because we could be incentivizing behaviors that optimize for the metric while actually being counterproductive to our goals. Lastly, we can also use metrics for continuous process improvement. So here we can answer questions of the form, are our processes effective? How can we improve them? In order to do this, we need to be able to benchmark the efficiency and effectiveness of our systems, so that we know when changes we've made have actually moved the needle in the right direction. And now, in order to support these functions, not only do we need well-defined metrics, but we also need an effective means of measuring and communicating them. Over the years, we've come to realize that this involves massive amounts of data and a whole bunch of people, processes, and technology. So this talk is looking at the question of how we can design our data architecture to better support these missions. Okay, we're now ready to go on a very brief history of metrics and data platforms. Let's go back in time 10 to 20 years ago and pretend we're a data analyst who's been asked the following question. What are the total sales for 2004 grouped by product category and region? With modern data warehouses, this would be a fairly trivial question to answer, but back then it'd probably be painfully slow because compute and memory were significantly more expensive, and also because data warehouses were typically row-oriented rather than column-oriented. The solution was to create tables of pre-calculated metrics, aggregated at every level for every dimension that you might need. These are referred to as OLAP cubes. OLAP for online analytical processing. Cube because they're multi-dimensional datasets driven by a star schema, with the dimensions being the axes of the cube. In this cube here, we can see the vertical axis contains the product category dimension, The horizontal axis contains the sales region dimension. And then going back into the screen, we have the dimension of time. And then also, each cell holds a pre-computed measure of interest, which is derived from the fact table. In this cube, that's sales counts. We can of course have more than 3 dimensions, it's just a bit hard to visualize. Okay, so this smaller pre-aggregated dataset now fits into memory, enabling real-time querying for common analytical operations, such as roll-up, slicing and dicing, drill down and drill up. The operation we want is slicing, where we take a rectangular subset of a cube by choosing a single value for one of its dimensions. If you want to dig deeper into the intuitions behind OLAP cubes, I'd highly recommend the great article, What's an OLAP Cube by Claire Carroll. Now let's look at how OLAP cubes would have fitted into the data architecture of the time. We can see here on the left some source data systems feeding into some transformations and then into the data warehouses. Now our OLAP cubes were populated from the data warehouses to support responsive querying. In order for BI tools to query the cubes, we required a lightweight data model referred to as a semantic layer. Because this also allowed us to combine metrics from across different data sources, we can also think of this as giving us a form of data virtualization. Now, our data analysts and other consumers can perform ad hoc querying of their desired metrics and create dashboards and scheduled reports. Some things to note about this setup is the close integration of cubes with BI tools. And also, if things are working well, our cubes are the only way to source our metrics. All our reporting goes through the cubes, which means that we actually have a standardized reporting process and a single source of metric truth. There were, however, some drawbacks to this arrangement. The cubes required frequent refreshing from the warehouse, and it takes time to model and populate a new data cube, as well as to update existing cubes in response to business changes. This was exacerbated by the fact that often it would be different teams from the consumers who would be responsible for doing this work. So OLAP cubes were frequently a bottleneck for the sourcing of timely metrics. Now around 10 years ago, we started to see the rise of massively parallel processing databases, or cloud data warehouses. These are columnar databases that support OLAP workloads over massive amounts of data. The impacts of scalable cloud compute and storage were quite profound. It meant that we could consolidate multiple fragmented data warehouses into one. It also meant that transformation could be moved to be performed within the warehouse. And importantly, for our narrative, it meant that the compute that was previously provided by OLAP cubes could be provided by data warehouses. For organizations that did away with their cubes, they meant that they no longer had to worry about them being bottlenecks to getting metrics. Consumers could query directly from the desired tables they needed without having to wait for updates to the cubes. Now, it also meant that they could query from a range of analytical data stores. I focused here on cloud data warehouses to simplify this narrative, but of course there's quite a range of systems that support scalable analytical queries in modern data ecosystems. This brings us to today and the dysfunction of metric sprawl. So without a standardized reporting flow, metrics can now be defined in a whole range of places. Firstly, metric definition is still often tightly integrated with BI tools. But there are many teams doing analytics across the organization, such as sales, marketing, finance, and product analytics. And it's not uncommon for them to be using different BI tools, meaning that metric logic will be found across each tool. Some metrics might be defined in tables in the data warehouse, but it's not possible to compute all aggregations ahead of time in the warehouse. So if a team needs it at a different level of aggregation, they'll probably just make a new table as needed. And then data science teams making data products will often need to use metrics, but if it's only available in places like BI tools, they'll probably end up redefining it in their own code bases. So the underlying issue here is that there's all too often no governance processes around the ownership, creation, and access of metrics. So that's our metric sprawls, but what's the dysfunctions associated with it? Well, each time an existing metric is re-implemented, we have rework, which is costly and inefficient. But also, metric definitions can diverge across teams over time. They could be implemented incorrectly initially as well. Maybe because the source of metric truth is actually a plain language description in an internal wiki, and each time it's recreated, there's a risk it'll be misinterpreted or implemented incorrectly. And so the consequences of these situations are worse. We could have decisions made on incorrect metrics, and in turn, that could result in a lack of trust in data. Consumers might decide that they need to re-implement it correctly themselves, thus compounding the problem. And decision makers might stop consulting the data entirely, which really amounts to a complete failure of one of the core mandates of an organization's data function. Let's now have a look at modern approaches to metric-driven data architectures that can help us with the problem of metric sprawl. So first up, we have the unified semantic layer. And we can kind of think about these as kind of like OLAP cubes in the cloud, in that they employ pre-aggregation and caching to offer low latency responses. Now, they overcome many of the limitations of traditional OLAP cubes by offering the elastically scalable compute and storage of the cloud. They're way easier to update their data models over time. And when the answer is not pre-calculated, unlike old school OLAP cubes, you can automatically fall back to the data source to run the direct query, albeit a little bit more slowly. So why you might want to adopt one of these? Well, first of all, they give you fast querying. So modern data warehouses are designed to be able to crunch massive data sets, but they're not really designed for super low latency responses. So if your workload involves lots of dynamic ad hoc querying, these could be helpful there. But importantly, from the perspective of our metrics, what they do is they give us a unified semantic model that standardizes the interface where we can consume by a number of different consumers. This means we can have a much thinner semantic layer in the consuming systems and consolidate and share metric logic across the different consumers, thereby avoiding rework and inconsistent definitions. Additionally, though, the other interesting thing about these is that they can actually consume from a range of different data sources, and also even across clouds. So what we're kind of getting here is sort of a bit of data virtualization, which is kind of a bit reminiscent of the semantic layer and OLAP cube setup we had back with traditional OLAP cubes. Now, these are some of the vendors that I came across in my research, branding themselves as unified semantic layers and cloud semantic layers. I haven't looked too closely at these offerings, but what I did notice is they tend to orient their data modeling approaches around no-code and assisted or augmented approaches to doing the data modeling. They have somewhat different approaches to doing the underlying sort of implementation. So I think if you're interested, if some of this sort of situation could meet your needs, I definitely think they're worth a closer look. We're now ready to talk about the rise of the metrics layer. Actually, first I want to talk about analytics engineering. This is a recent trend that I think plays a key role in informing the emerging metrics layer. This involves analytics engineers writing code to transform, deploy, and document curated data for consumers, giving us the benefits of version control, testing, modular reuse, and reproducibility across environments. These are all things the last 50 years of software engineering have taught us increase the reliability of digital products and improve the efficiency of delivery. So why wouldn't we want to apply this to data modeling? Now, the most celebrated poster child of analytics engineering is probably dbt, which allows analytics engineers to manage transformations within the data warehouse, allowing them to perform dimensional modeling required for analytics consumers. Moving right in the data flow, but back in time a little, we have LookML. This is the configuration language by the BI tool Looker to perform metric modeling. This is the same metric logic found within the semantic layer of BI tools, but now it's defined in code. And we really have to give credit to Looker here for this innovative step back in 2012. And it's almost like Looker was going for a single producer to many consumer model, but possibly it was just a bit ahead of its time, and so the only real consumer for LookML today is Looker itself. But people like LookML so much that I've actually heard of some data teams coercing other clients to consume from the Looker server. One question you might have is why not use dbt as a metrics modeling tool? And here I'm going to defer to Tristan Handy from Fishtown Analytics to explain the strengths of each. Analysts use dbt to clean, reshape, and pre-aggregate data. Analysts use LookML to build a metadata layer that allows Looker to write SQL queries against your schema. Use dbt to build your foundation, then use LookML to teach Looker how to navigate it. And lastly, I want to just mention Cube.js. It's another tool that gives us metric modeling in code, but rather than serving BI tools, it creates APIs designed to be consumed by data apps defined in front-end frameworks like React and Vue. Looking at all these three tools together, some things they have in common are they all use analytics as code, they have templated SQL, and we also see SQL compilation to support multiple backing data stores. And these are all innovations we'll be seeing again soon in the metrics layer. And this brings us to the metrics layer. Earlier this year, I posted on the locally optimistic Slack. Anyone else thinking about cloud semantic layers, metric stores, headless BI? This prompted a whole flurry of excited conversations, and I realized that a whole lot of people had been thinking about this space. I've since come across so many awesome articles in this topic, all posted this year, that I figured, well, this deserves a montage. So the overarching theme across these articles is that the metrics layer represents a component in the modern data stack that serves as a centralized repository for defining and publishing metrics across the organization, providing a single source of metric truth and enabling standardized reporting and analytics. Looking at the difference between typical data ecosystems on the left with metric sprawl and ones that adopt a metrics layer, we can see a core dynamic separating them is that the metrics layer has a decoupling of metric definition from consumption. Now you might think this looks similar to unified semantic layers, but I think there's a few differences going on. Firstly, metrics layers treat metrics as first-class concerns. Secondly, they model metrics as code, whereas the unified semantics layer tended to use no-code approaches or even automated approaches to modeling. Then lastly, the metrics layer also has a stronger focus on governance and the publication of metrics across the organization. Just lastly, a quick note on the term metrics layer. This comes from Ben Stansel's excellent article, The Missing Piece of the Modern Data Stack. And I think I like this term a little bit better than headless BI, another one people are using, since there are many different types of consumers in the modern organization beyond those teams using BI tools, such as data science teams, machine learning data products, and SaaS integrations. So here's my take on the key characteristics of a metrics layer solution. Centralized. Create a single source of metric truth to avoid the dysfunctions of metric sprawl. Definition. Define metrics as code. This allows us to apply software engineering best practices that we know promote reliability. But at the same time, we have to get the abstraction right so that we provide the appropriate semantics for metrics. Governance. We need to enforce standardized processes while at the same time enabling teams to manage metric creation, ownership, and access. Publishing. It's not enough just to define metrics. We have to make them discoverable by consumers across the organization. We also need to make them understandable by providing documentation around their context and lineage. Interfaces. Given that we want to serve a diverse range of consumers, we need to provide interfaces that enables different user personas to connect using the tools of their trade. So for SQL access via BI tools, we need things like JDBC and ODBC drivers. For data science and embedded analytics teams, they're probably going to need things more like REST APIs and maybe SDKs in different languages built on top of them. Lastly, performance. We need to ensure that metric queries are responsive. Now there's two broad types of approaches that I've seen on this front. First of all, we can use low latency OLAP engines that might need to be synchronized with the source of truth data store. Or we can use cloud data warehouses, which tend to have higher latencies, but it also means you don't need to do any synchronization. And then we have to maybe use some pre-aggregation or clever caching to achieve the low latency query results that we're after. The second flavor of metrics-driven architecture that I want to talk about is to roll your own metrics layer that meets all the criteria that I just outlined. Now all the companies you see here, Airbnb, Uber, and LinkedIn, they all decided that access to standardized and trusted metrics was such a priority that they built out their own metrics layer solution. And they've all decided to write publicly about them. Airbnb in particular is notable for two great write-ups on Medium about Minerva, their metrics layer solution, which I definitely recommend checking out. It's also interesting, I think, to contemplate why these three companies decided to invest so heavily here. And I think I'd point out the fact that their primary products are data products that I'm willing to bet have a whole bunch of machine learning models running in production. And, so BAU for running these models over time is doing a bunch of A/B experiments to try and test out the results of changes to those models and to see if they actually resulted in improved value for the customers. A good way to do that is to identify a bunch of metrics that are proxies for that value that you can get a faster feedback loop on, and then make those metrics available to data scientists and ML engineers in order to make quicker changes. The other thing that I think is interesting about these three companies is that, well, they're very large enterprise scale companies. In fact, they all have over 15,000 employees. So I think that probably sort of also points to the other fact that building out a metrics layer to the scale that they have is probably quite a costly exercise. And this is not an option that's available necessarily to many orgs. But I also have a hunch that there are many organizations out there that have rolled something similar to this to meet some of these needs, but possibly just don't have as much, quite a degree of comprehensive functionality as them, and also haven't written up blog posts about it. And now for our third and final flavor of metrics-driven data architectures, we have metric stores. They're an emerging component in the data ecosystem, aiming to provide you with a complete metrics layer solution. They're positioned to slot into the modern data stack, treating your data warehouse as the source of truth, proxying data from the warehouse rather than ingesting and moving it. They embrace metrics as code and analytics engineering philosophies by giving you appropriate abstractions for metric modeling and querying. As part of that, you get a declarative deconfiguration that automatically generates SQL to perform pre-aggregation and denormalization logic needed to get those low latency queries from the warehouse. Let's have a look at some notable players in this space. Firstly, we have Transform. They were founded by some folk who spent time working with the Minerva Airbnb data metric store. Some callouts on this one. They have a pretty cool looking metrics catalog, which gives you a user interface providing consumers with metric discovery, documentation, and lineage. On the publishing side of things, they have a nifty looking GraphQL-based metrics API exposing metric metadata and query results. Kind of looks to me like this might be the most feature-complete metrics layer solution out of the metric stores here. Then we have MetricQL. They're a recently released open source tool by the makers of Rakam, a product analytics service. And this is sort of based on their insights and experience while working with their clients. Big call out here is that it has strong DBT integration. So actually leveraging your existing DBT models to help with defining your metrics. Then we have gooddata.cn from the Good Data people, makers of BI and embedded analytics solution. They've been around for a bit over 10 years, I think. And I think that sort of history shows because they have a strong array of BI-related integrations, including programming language SDKs, support for embedded analytics, and self-serve BI interfaces. They still adopt metrics as code, but they also have a visual interface for modeling on top of that lower semantic layer, which seems to be where a lot of the focus is on. Then we have Supergrain, which I can't tell you too much about because it's still under development, but it looks like this is going to be a pretty compelling offering, so I reckon watch them. And then we also have Cube.js, which I mentioned before. It's a little different from the others in that it's not aiming to be a metric provider for the whole organization. Instead, it's an open source metric store specifically for embedded analytics. So for creating front-end web apps with visualizations consuming metrics from your warehouse over REST APIs. So if you need to serve a large collection of custom data apps in the browser, this is definitely one to take a look at, I reckon. And just a note here that I've not actually used any of these myself. So if you've, I'm certainly keen to, but if you've got any experiences, reach out to me. I'd love to chat. Now that we've looked at some architectures, we can identify some design choices for metrics management. First up, we have your metric modeling strategy. We've seen no code and automated metrics modeling, and then we've seen metrics as code and analytics engineering. In terms of OLAP data strategy, we've seen ingesting from potentially heterogeneous data sources into OLAP engines, and then we've seen proxying from the data warehouse. I think the interesting thing here is that these different decisions can be kind of mapped on into some of the historical trends we've looked at. First up, we have unified semantic layers, which their lineage can be traced from OLAP cubes in enterprise contexts, with visual interfaces for modeling geared towards business analysts, and an emphasis on data virtualization across multiple data sources. Metric stores, on the other hand, are born out of the modern data stack, using analytics engineering approaches to metric modeling, and also treating the data warehouse as the source of truth. Now, if you're rolling your own solution, you can pick and match from these different strategies. I think with the OLAP strategy, it's going to be somewhat dependent on your existing architecture and your use case. In terms of the metric modeling strategy, this is kind of interesting because it sort of brings us back to the heart of why analytics functions separated from IT functions, where we saw bottlenecks and long waits due to handover points across technical teams and business domain experts. I kind of reckon that analytics engineering is the way forward here, but we do need to address the bottlenecks that engineering processes can introduce by training analyst folk with engineering skills and orienting work around cross-functional product teams so that we don't need to hand over to technical specialists. So to sum up and leave you with some parting thoughts, I started by arguing that metrics are crucial for supporting decision-making, goal setting, and continuous improvement, and that we need to work towards eliminating the costly dysfunctions of metric sprawl by enabling the availability of standardized and trusted metrics that are accessible across the organization. And I think to do this, we should be looking to make metrics a first-class concern of our data architectures. So consider adopting or building tooling to assist with this. And lastly, watch this space, because I reckon it's going to go places. And I just wanted to finish by saying thank you for tuning in, and a massive thank you to everyone who's generously given me a bunch of their time to talk about these ideas. This is a space that I'm somewhat newer to, and so most of the stuff that I've presented here is really a synthesis of ideas from folk who have been playing in this space for longer than I have. If you want to chat to me about any of this stuff, please do feel free to reach out and ping me on any of the channels that you see here. And thanks a lot. Bye.